Um, so my talk today is intrusive magmatism and intrusive volcanism in the Apollo Basin Chang'e landing site. I'm Yu Chen from the University of Hong Kong. And as we all know, Chang'e 6 mission is China's and the world's first fossil sample return mission. It successfully returned 1935 grams of lunar soils from the lunar far side. And the landing site is in the South Pole Icon Basin, and the exact location is in the south of Apollo Basin. The landing site is in a transitional zone between Spaca, Mg pyroxene annulus, and heterogeneous annulus. Therefore, the materials from returned by Chang'e 6 will be very diverse that could help us answer lots of scientific questions. And here are the questions that I list. This diagram shows a survey of over 200 Chinese scientists, and these are the main scientific questions that can be answered by Chang'e 6 samples according to our survey, and also a white book by Brad Jolliffe and the report of endurance. Therefore, any samples from South Pole Icon Basin are very important to our understanding of the moon. And let's go more closer to the Apollo Basin. As we can see from this video images, there are at least 5 mare units in this region, and I call them Central Mare, Western Mare, Southeastern Mare, and Northwestern Mare. Chang'e 6 landed in the Southern Mare. There are lots of special volcanic features in this region, including volcanic mesas, volcanic domes, and volcanic depressions. They are all very special, and we don't have good explanation for them as for now. But they are very special, reflecting the special volcanism in this region. And Chang'e 6 landed in the Southern Mare, and in the middle of the Southern Mare, it has an area of around 9,000 square kilometers with a mean elevation of around minus 5,000 meters. And this is clementine, titanium, and iron data. As you can see from these 2 images, it's very easy to identify at least 2 episodes of eruptions in this region, and the one in the west has a relative high titanium and iron abundance, and the one in the east has a relative lower titanium and iron abundance. And I also extract the spectra of small fresh craters of each mare unit here, and you can see that they all have very typical absorptions of pyroxene or mare basalts. And I also calculate their band 1 and band 2 center of each extracted spectra, and it shows that they are maybe dominated by clinopyroxene. And I also did some quantitative work of the composition of each mare unit, and recently Chinese scientists already studied the mare of the Chang'e 6 samples, and this is the work of Li et al. According to their work, Chang'e 6, the return samples are mainly composed of low titanium mare basalts. Based on the basaltic lithic from the Chang'e 6 samples, it has a titanium abundance of around 5, and according to the remote sensing work, the titanium abundance is around 6. So they are very close to each other, and you can see based on the return samples, the scientists already distinguish low titanium and very low titanium mare basalts in the samples, and they correspond well with the Southern Mare Unit West and the Southern Mare Unit East here. And there may be some high titanium mare basalts that we didn't distinguish from the samples yet, but we already see them from remote sensing. And here is, I propose that the relative high titanium mare basalts may be overlaying on the low titanium mare basalts with a decrease in thickness, because I did considering the thickness by the crater excavation technique. And I also find that there are tons of volcanic features to the west of Chang'e S crater. Therefore, I propose the relative high titanium mare basalts may be erupted from the west of Southern Mare and flow east with decreasing thickness. And it counted a Winkle radius, therefore it stopped here. And not only for the Chang'e 6 landing site, but also for the Chang'e 5 landing site, we have distinguished a phenomenon that the relative high titanium mare basalts overlaying erupted later than the relative low titanium mare basalts and overlaying on it. And this phenomenon is not only found for the Chang'e 5 and Chang'e 6 landing sites, but also for Chang'e 3 and for the Poseidon Keapi terrain. Therefore, Chang'e 6 samples maybe can help us answer why is the relative high titanium mirror basalts evolved from the relative low titanium mirror basalt sources. And not only the mirror basalts, we also find there are probably some cryptomaria to the south of the Chang'e 6 sampling site. Cryptomaria are the products of ancient lunar volcanism, and at least there are one fragment. It is a high aluminum basalt. It is identified in the Chang'e 6 samples, and it has an age of 4.2 gigayear. But there are maybe even more cryptomaria class in the Chang'e 5, in the Chang'e 6 samples can help us answer when did lunar volcanism start on the moon. Therefore, based on remote sensing and the return samples, the volcanism at the Apollo Basin is extended at least from 4.2 gigayear to 2.8 gigayear. There is even some very young volcanism in the northwest of the Apollo Basin with an age of 1.8 gigayear. And not only extrusive volcanism, I also find there are maybe lots of intrusive magmatism in this region, including in three types. One is flow fracture craters, seals under flow fracture craters, and as ring and linear dikes, actually according to the estimation of gray data, the intrusive volcanism has a volume 70 times of effusive volcanism in and surrounding the Apollo Basin. And also, I find that magnesium Mg suit should be present in the Apollo Basin according to the moon mirage map data. According to the moon mirage map data, the western peak ring of Apollo Basin is rich in magnesium, and I propose that maybe Apollo Basin exhibit ancient Mg suite intrusions, and Apollo Basin is ancient, but the craters overlaying on the Apollo Basin, like Chaff S crater, can exhibit, redistribute those Mg suite materials to the Chang'e 6 samples and can help us to answer how did secondary crust building on the moon. And not for the Chang'e 6 samples, the largest question that can be answered is the lunar dichotomy. And the lunar dichotomy is best manifested by its maestro in mirror distributions. And there are two kinds of explanations there are two kinds of hypotheses to explain their maestro. One is the crustal thickness difference between near side and far side. Another one is the critical element differences between near side and far side. And for the Chang'e 6 landing side, I have found that the mirror crustal thickness can control the mirror volcanism or can control the volcanic activities in this region. For relative thick crustal region, there are no eruptions. And for the intermediate crustal region, the magma can extrude to the floor of craters to form flow fracture craters.
2 minutes.
Okay. And for the thin crust region, it can erupt to the surface to form like cryptomaria, mirror basalts, such as Sparka. And this phenomenon is actually not new. Jennifer Wheaton and Jim had found this for the Oriental Basin. And the creep elements is also maybe a key here that can explain the maestro in mirror distributions. For the Chang'e 6 samples from the lunar far side, it's very depleted in heat-producing elements. Therefore, crustal thickness and heat-producing elements maybe can together explain the mirror maestro. This is a summary slide on my presentation. There are at least 2 episodes of eruptions in the southern mirror that Chang'e 6 landed. And the mantle source may be evolved from a relative low titanium to relative high titanium to produce continuous eruption in the Apollo Basin, not only Apollo Basin, but Chang'e 6, Chang'e 5, Chang'e 3, Chang'e 5 landing sites, as well as globally, maybe in the Poseidon Keapi terrain. And crustal thickness can control volcanism in this region, and creep elements might control the distribution of mirror volcanism for the near side and far side. And there are lots of plutonic rocks in the Chang'e 7 in the Chang'e 6 samples, all those different components can help us to answer different kinds of scientific questions related to the early evolution and the thermal history of the moon. And therefore, we are very excited to study them. So that's all for my presentation. Thanks.